Hello and welcome to ACI's eRCM Thermodynamics training session. My name is Dwayne Hickman. Today's short session will cover the fundamental features of this software. ACI's eRCM Thermodynamics for compression software is the ideal program for estimating minimum power required to compress gas, regardless of the type of compressor being used. This simple and easy-to-use software provides a wide range of thermodynamic gas properties that are critical items when compressing gas. Let's take a short adventure and see how this software may benefit you. Some of the most common uses for eRCM Thermo are determining phase diagrams, mixing two gases together, calculating critical gas properties, estimating power required to compress gas, simulating multiple stages of compression, using the software with various types of compressors such as centrifugals, rotary screws, diaphragms, axial, and reciprocating. After running the software, we're going to enter in a gas analysis. While the total mole percent does not have to be exactly 100%, it will need to be somewhere between 98 and 101%. A couple shortcuts here. First, you can right-click over this table and select a predefined gas analysis. And second, if the component does not total up to 100%, then simply right-click over the column and choose to normalize the gas. The amount of water in the gas is based upon the relative humidity value, or you can enter that amount directly. To enter it directly, set the relative humidity to user entered and then include the percent of water in the gas input table. eRCM Thermo supports about 400 component gases. Any one mixture can use up to about 30 of these individual components. Once a valid gas composition is entered, corresponding gas properties are displayed in the upper right section of the software. Columns of results cover gas at suction inlet conditions, discharge conditions, and at final after the cooler conditions. Suction, discharge, and cooler settings can be changed via the inputs in the lower right section of the software. New values can be entered directly, or you can drag a properties slider to dynamically change those values to quickly review how those changes affect other outputs. eRCM Thermo supports a wide range of units of measures. If you prefer different units, click on Options in the menu bar, then select Units of Measure, and then set to desired units. The scrubber liquid columns report composition and amount in the below table of liquids that formed during the cooling process. For this example, enter a flow rate of 20 million standard cubic feet per day into the compressor at current conditions. If the inlet gas's temperature is raised from 65 to 120 degrees Fahrenheit, the inlet stream will hold more water. Thus, during its cooling phase, much of that water will drop out. To estimate the power required for compression, enter a compressor flow value in the lower middle of the form. The minimum amount of power required based on enthalpy at suction and discharge will show in the lower right of the form. Divide this value by the compressor's isentropic efficiency to obtain a more realistic power required to compress the specified volume of gas for that specific compressor. To identify areas of concern related to liquids formation, generate the gas stream's phase envelope. The phase envelope shows a pressure versus temperature map and indicates regions where water starts to drop out, where hydrates start to form, where component gas starts to drop out, and where regions are all solids, all liquids, or all vapors. Modeling the fluid properly as it flows through the system is critical. User's initial gas stream is first adjusted for relative humidity at inlet pressures and temperatures when appropriate. Then the fluid is flashed at inlet conditions. This flashing may identify liquids that will be removed at the scrubber. The remaining vapor phase of the fluid then enters the compressor and is compressed. This same vapor phase is then flashed at the cooler based upon the discharge pressure and cooler temperature. If a side stream is present, it will be mixed with that fluid from the cooler based on respective gas analysis and gas temperatures. The resulting mixture is then flashed at the scrubber where any resulting liquids are then removed. and the remaining vapor phase of that fluid continues through to the next stage of compression or to its final destination. To mix two gas streams together, such as when a side stream gas mixes with the main compressed gas, enter a side stream gas analysis and then enter in the flow rate of that side stream. To simulate multiple stages of compression, with liquids potentially dropping out between stages, in the upper right corner of the form, advance the process number to the next process, and then elect to link that process to the earlier process by checking the link box. Now, outputs such as gas composition, pressure, temperature, and flow rate from the previous process will be used as inputs into the current process. This effectively connects the two processes together to simulate multiple stages of compression. Thank you for watching ACI's brief training video covering eRCM Thermodynamics for compression software. For more information about ACI, ACI hardware products, and/or ACI software products, please contact one of the ACI team members listed here. Thank you.